Welcome to Beginning Python. I'm going to give just a minute first to check that everyone's got Anaconda started up and have able to launch it and get it all working. So just take a minute now to start Anaconda Navigator, and if you can, also start JupyterLab. And in just a moment, I'll start going through that myself, and those who haven't got it set up themselves can hopefully follow along and be ready to get started. So the way to start Anaconda Navigator will depend on which operating system you're on. It varies from place to place, but hopefully the instructions that were provided with it gave you the ability to get at least as far as a window that looks something like this one here. So it's the green Anaconda Navigator with the circle and a bunch of tiles on the screen as well. Anaconda Navigator is the way that we are getting access to Python. So Python is provided for free. It is a completely free and open source piece of software. There are lots of ways to get it installed onto your system, but one of the easiest that we found, particularly for these training sessions, is the Anaconda system. So Anaconda provides us with the programming language Python, as well as a bunch of tools which we can use to write and run Python scripts. Some are basic tools and some are very advanced, and you see a selection of some of these on the screen here. For the course today, we are going to be using a tool called JupyterLab. Note that JupyterLab is different to Jupyter Notebook. JupyterLab is a web-based, simple development environment which allows us to write and run Python scripts and more, but that's the extent that we're going to be using it for today. So go ahead and press the launch button on the JupyterLab tile, and I'll do the same, and that should open up in a web browser the JupyterLab environment. Takes a few moments, you see, your web browser should pop up. It thinks about it quite hard, you get spinny things, and then we are here. And with that, I'm going to put Anaconda Navigator away, make this full screen, and nice and big. So you should end up in an environment something like this. If you've already followed through the video explaining how this stuff gets set up, then you'll automatically be left in the environment you last left it in. So it should all be laid out correctly. So the things we're going to be doing in the session today is writing Python scripts and running Python scripts. So there's two different tools that we are going to be using. Firstly, we're going to be using the text file environment to write our Python scripts. So I click on text file, and that has opened up this whole window here as a text file. It's just a text editor. I'm then going to open a terminal. To do that, I click in the plus in the top left, and then at the bottom here, I press terminal. I now have a terminal covering my screen. To make it easier to see everything that's going on at once, I'm going to click and drag on the terminal tab over to the right hand side so that I have the text editor on one side and the terminal on the other. This is all covered in the first video that we sent out, so if anything here isn't working or you've just missed what I did, feel free to have a look at that first video. It's only a few minutes long to catch yourself up. I'm just going to do something which you don't need to do, so ignore this. It's because I've got my files in a special place to avoid confusing things. There we go. So we're going to start off by writing our very first Python script. But before I jump ahead and do that, I'm just going to give you all 30 seconds or so to make sure you're up to speed with this. You've got your text file open, you've got your terminal open, and it looks largely the same as what you see on my screen. Bear in mind, anything you have in this bit on the right might look slightly different, but it's basically the same. Hopefully everyone has now got their environment set up like you see on the screen here. So we're going to go ahead and run our first Python script. So before we can run any Python code, we first need to write some code. So let's go over to the text editor on the left hand side. And the first thing we want to do, because currently this file is called untitled.txt, the first thing we want to do is rename this file so that it has the correct file extension. So Python file should end with .py, not .txt. And secondly, untitled is a undescriptive name for what we're going to be doing. So if you right click on the file name in the file browser on the left hand side and go down to rename. So right click and rename. And we're going to select all of that text, including the .txt, and I'm going to call it script.py. And then press enter. And you'll see it's renamed here and it's renamed up here. You should also see that the little icon next to it has now changed into the logo of the Python programming language, so we know that it's understanding that this is a Python file. With that, we can go ahead and start writing our Python code. We're going to start with what is probably the simplest Python program you can write, and I'm going to explain the different components that go into it, and from there we're going to build up into more and more advanced scripts as we go through the session this afternoon. So the first thing we do is write the word print. All lowercase, and without any spaces before or after the word, and we follow that with an opening and a closing round bracket. This is the print function. Functions in Python are usually lowercase. They can't have any spaces in the name of the function, and a function is called by following it with an opening and a closing round bracket. Some functions don't take any different parameters or arguments, so they don't have anything in between the round brackets. The print function, however, does take arguments, and the arguments it takes are things that we want to display onto the screen. So to give information into the print function, we have to put something in between those two round brackets. So what we're going to put inside there is some words. We're going to ask it to display some words onto the screen. The way that you represent words, or as they're known in Python, strings, is using pairs of double quotes. So if you do a double quote and another pair of double quotes, and then in between them we write hello. So what we have here is the word print, followed by an opening round bracket saying that we are calling the function. Then we have the thing that we're giving to the function, the information that we want the function to process, followed by a closing round bracket to say that we've finished giving information to the function. You'll notice here that the text has been coloured green and red and so on. The specific colours aren't really important, it's just the way that the text editor gives us a bit of information. So it's telling us that it's understanding what's been written. Other editors that you can use won't have this particular colours. They might use blue and red or blue and pink or any other colours in principle. The other thing to note is that the text here is just plain old text. There's nothing special about the program that we're running this in. We can write Python scripts in a basic text editor like Notepad, or you can use advanced integrated development environments like Visual Studio. All of them work in the same way. They're writing simple text files which are then going to be interpreted as Python code. So in order to run this script, first thing we need to do is make sure it's saved. So one way to do that, I think, is to go to File and Save Python File. Make sure you always save your scripts before you run them. Now that we've saved that file, we can go over to the terminal. So we're going to write our Python scripts on the left and run them on the right. To run your Python script, there's a few different ways you can run your Python script, and I went through the options for that in the second video that was linked and it's been posted in the chat. So if you get any errors coming up, go and check out that second video, and that will explain what the other methods are and what kind of error message you might see, and have a go at them. And if that doesn't work, let us know in the chat and we'll give you a hand. But the way I'm going to be doing it on my screen is by running the program Python. So I just write the word Python, ignore the $sign, that's just something that's built into my terminal. That's there by default, you see, that's just telling me that this is a terminal. I write the word Python, followed by a space, and then I give it the name of the script I want it to read, scripts.py. And so what's going to happen here is that this program here, which is called Python with a lowercase p, is going to read the file that I give it, which is this text file over here, and it is going to read that file one line at a time. It's going to look at the text on that line, it's going to interpret it, assuming that it's written in the language Python. Python is a language as well as a program. So as long as we've written some text in this file in the Python language, then the Python program is going to be able to understand it and do the things that we've asked it to. It's going to read it one line at a time and do the things on that line, then read the next line and do the things on that next line, and so on until it gets to the end of the file, at which point it will exit and say, I'm all done, success. So to tell it to actually kick off that process, in the terminal over here, after writing Python space script.py, we just press enter. And we see here it has done what we've asked it to. it has printed. This is a bit of computer jargon. Print in computer jargon generally means display on the screen. It doesn't literally mean print out of a printer. It's a holdover from the olden days of computing, when everything was literally printed out on a printer. But it's displayed the text on the screen, hello, the same as we wrote in our file over here. It has then returned us back to the terminal prompt, the same as it was before, with a flashing cursor, ready for us to run the same thing again. So I'm just going to give you a minute or so now to have a go at doing that yourself. I'm also going to point you at the course notes. So what we're going through here, at the bottom of the first page is a next link. We're having a go at the chapter titled Getting Started here. On the whole, I'm going to be just doing the examples as they are in the notes, and I'll hopefully have Gareth keeping us topped up and tracked as to which chapter we're on. But here we are just going through this very first chapter titled Getting Started, in which we've written a text file and we've run that text file, and then a little bit of an explanation about how that all works, which I've just gone through. So have a go at that yourself, just take a minute or so, and if that's all working, then we're going to carry on in about 1 minute. That should be enough time. Mengdi, so the colour in the terminal doesn't matter at all. Mine is all multicoloured because I'm running ZSH on Linux, which has been set up to be all multicoloured. On most systems, it's just going to be plain black. So if you see hello printed out, then everything's working great. Some questions from Livia and Bryony saying you're getting syntax error, invalid syntax. That's, again, a number of different ways that this can be caused. There's two main types of errors that Python has. There's errors that happen while the program's running, like you've tried to divide by 0, or you're trying to use some information that it doesn't know is there. The other type of error is a syntax error, and that's when your file is written in something which isn't valid Python language. So the first thing to check is that your Python script looks exactly the same as it does over here. That you're using double quotes and not backticks or anything like that. That you're using round brackets and not square brackets or curly brackets. And that everything is in the same lowercase print as you see here. Do you get anything else printed out in the terminal apart from the syntax error? Could you copy and paste the entire thing of you running the script and the output in the chat, and that might help me work out what's going on there. Okay, I see what's going on here. So this will happen if you've accidentally got yourself stuck in the Python interpreter. There's a thing that happens if you just type Python and press enter. So don't do this, I'm just demonstrating. If you do this, you end up in an environment where you've got these 3 arrows here. Now this is like a terminal, but it's slightly different. If you end up there, type exit and then open and close round bracket and press enter. And you should end up back at the non-3 arrow terminal. Once you're back at the normal terminal, you should be able to type Python script.py and you should get the text printed out. So I'm just going to clear my terminal on the screen there so that it has a bit more space. Don't worry about doing it yourself, just clearing out what we see. So in Python, there are a bunch of different types of data that you can have. The types of information we've used so far has only been one type of data. We have had a string. They're called strings because they're kind of like a string of letters chained together. It's another bit of jargon which you will get used to. So we have a string here. Hello is a string. Strings are designated by having open quotes at the beginning and open quotes at the end. But as well as strings, there are also different kinds of data types. I'm just going to run the script over here. As a shortcut and a tip, if you're in the terminal and you press the up key on the keyboard just once, it will bring up the previous command you ran. So you can press up on the keyboard and then press enter, and it will rerun that same previous script. I'm going to change this print function here now so that it prints something else. So instead of printing hello world, I'm going to print a number. So 3.14159, that's more than enough digits of pi. You'll see here that the number is green, where the string was red. That's just a decision that the highlighting in this text editor has decided. Again, the colours aren't particularly important. They're just there as a visual aid. You'll notice again there's a black circle here, and I pointed this out in the video, but make sure that before you run your script, you save the file. On Windows and Linux, it's Control S, and on Mac, it's Command S to save the file, or you can go to File, Save Python File. I'm going to use Control S. So now if I run the script by pressing up and enter, we get our number printed out. Okay, so we've got strings, we've got numbers, and we also have integers, which don't have decimal places. That works very well. So if we save that and run that, we just get the number 3 getting printed out. So Sam in the chat is asking, why don't you need quotes for numbers? So the reason for that is Python uses syntax to work out what you're trying to tell it. There are fundamentally different types of data that you deal with in programs. There are words which as a human you interact with because you're trying to describe something to someone, like saying hello. And when Python is reading this, it will see the string and it will say, okay, I know that you're not, this stuff inside the quotes isn't special in any way. It's just something that a human will understand, and I don't need to worry about what's inside those quotes. If it sees just as it's reading along the line, one letter, one letter, one letter, and it gets to here and it sees a number that's not inside quotes, it's going to treat it as that particular mathematical number. And it's important because something we're about to see in a moment, that mathematical numbers in Python you can do maths to. You can do 3 times 2 or 3 divided by 4, and that's going to give you another number. Whereas something like hello, it doesn't make sense to divide hello in quotes by 3 because there's no description of how you divide a string by a number. And so by being explicit from the beginning about what kind of data you're dealing with, it lets Python know what kind of operations can be done to it. A thing to be aware of is that the string 3 is different to the number 3. This one up here, Python will just see as some words which humans understand and it doesn't have to care about. This second one here, it will see as the mathematical number 3, which it can do something with. So anytime you're dealing with numbers in Python, generally you won't put any quotes around it because you want the mathematical concept to be the thing that you're talking about. That said, it is sometimes useful to be able to talk about the types of data you're dealing with in a more kind of abstract sense. So in that example there, we just had a print function and we were just throwing the thing that we wanted to be printed straight inside those double brackets, and it was reading whatever we passed in and it was printing out to the screen. It's quite common to want to give names to your data so that you can refer to it multiple times, or to work as an aid to the reader so they understand what's going on. So for example, 1.3.14, that's good enough. Here we have a Python script which doesn't do anything. It's simply a number. So this here is a piece of data. We can give data names by assigning what's called a variable. And the way that you assign a variable to a piece of data, or assign a name to a piece of data, is by writing the name of the variable you want to create, followed by an equal sign, followed by the piece of data. So this is going to make a new name pi, which contains the value 3.14. This means that later on in our script, we can write print, and instead of writing 3.14, we can go ahead and replace the number literal that we would have put there with the variable name pi. And so when print pi gets read by the Python interpreter, it's going to say, okay, here's some letters. They're not numbers, they're not in quotes, so this must be a variable name. It's going to look up what that variable name is. It's going to see that it's this value here. And so 3.14 is what is going to be printed. So if I save this file and run the script, we see that it prints out 3.14. From the outside, it's looking basically exactly the same, but inside, we've broken it up into 2 parts. The parts dealing with our data and the part dealing with our output. So take a minute or two now to have a go at that yourself. Take any print function you want to do, anything that you'd want to print, but break it up over 2 lines. One line which takes that thing that you want to print and gives it a name, and then another line which has a print function which accepts that name as an argument and check that it prints the correct thing to the screen. Be aware that variable names can't have spaces in, they can't start with a number, and there's a few other constraints which you might find as you go along. I've introduced variables. A variable is a way of giving a name to data. And so in your head, it's worth having a sense of the difference between a piece of data, like 3.14, and a variable like pi. They can often be used in the same context, but they're fundamentally different elements of the language. So it's worth kind of working out in your head as we're going through the exercise, thinking about how data and variable names differ from each other. We've always seen a few ways. For example, a string has quotes around it, and a variable name doesn't, so they look different, but they also serve slightly different roles in the language. So hopefully, as we go through, you'll start seeing how that works. So I'm going to delete all this text and start with something different. So let's make a variable called distance in miles. And you'll see here I've used underscores between the words. There's a convention in Python to write your variable names as lowercase, to use full words in your variable names, and anywhere where there would be a space to use an underscore. Other languages have other conventions, but this is the general convention in Python, and it's the one I'll be following. And let's give it a value 30. So here we just have a number 30, which has no context or no information about it. Because we've got context here in the name of the variable that it says distance in miles, that tells us what this 30 actually represents. And so it's useful when writing Python scripts to give your variables descriptive names, because it will help you understand what the numbers actually mean. If I want to make another variable called distance in kilometers, I could go ahead and just assign this a value. Now I don't even know what that would be, but it'd probably be something like 50 or so. But of course that is not using the computer to my advantage. I could Google it, find out what 30 miles in kilometers is and write the value in here. But a more flexible and reusable approach is to work out what the conversion factor is and to do that conversion ourselves in our code so that we can change one variable and always have the other one automatically updated. And so when assigning a variable, on the right-hand side, you can do more than just write a piece of data. You can also refer to other variables. For example, distance in miles, and we can multiply that by a number. And I'm going to copy the number from down here to avoid errors. So here we made a new variable, and the value of this second variable is based on another one. So then when we print distance in kilometers, and then I save this file and clear it and run it, we see printed out it's 48.2. It's about 50, but it's a much more precise answer. This means that we can come back to our original script and we can change this to be 5,000 miles, and we can find out what 5,000 miles is in kilometers just by changing one number, rerunning the script, and we find out that it's about 8,000 kilometers. So this is starting to show the value of using variables rather than hard coding your numbers. It's also showing you how you can use variables which are based on other variables. As well as multiplication, there are other mathematical things that we can do. So I'm just going to copy and paste this one from my notes down here. No one wants to sit here watching me type all day. And so here we have a variable which is a floating point number, a decimal place number on the right hand side. We're making a new number which is that plus something, and then we're printing that out. In Python there are 4 primary mathematical operations you can do. Plus, well, uses the plus sign. Minus uses the minus sign, as you would expect. For multiplication, it uses a star. And for division, you use a slash. So those are the 4 primary different types of operations that you can do to mathematical numbers in Python. Going back to Mendy's question earlier about why some things are in quotes and why some aren't, I'm going to show you an example now of how Python sees the differences between those two types of data in the program. So I'm going to make a variable here, and I'm just going to call it my underscore number, and I'm going to set it to 67. and I'm then going to say my other number equals my underscore number plus 100. And then I'm going to print my other number. So we run this script, we get the kilometre thing and the Celsius thing printed out, and we get 167 printed. So it's successfully printing out the thing that we had. If, however, we put this 67 in quotes, Python is no longer seeing my number as being an integer. It's no longer seeing it as being a mathematical object. It's seeing it as being a text type object. And it doesn't know how to do mathematical things to text objects. So if we now run our script, we will see the first of our Python errors. It is unable to do the addition operation because it's no longer doing it to two numbers. It's trying to add a bunch of letters and a number together. And it's going to say that it's assuming that you made a mistake. It's not going to just implicitly convert something. It's going to make sure that you're going to be explicit about what you're doing. And so if we look at the error over here, the way that I read Python errors is by starting on the last line. It says type error. So that's telling it it's an error to do with data types, where types are things like strings or floats or integers. The error message itself is saying it can only concatenate strings and strings. Remember, this is a string, which means that my number is a string, which means that we're doing my number, which is a string, plus an integer. And so it's interpreting this as us trying to take one set of letters and stick another set of letters on the end. And that's what concatenating string to string would mean. Concatenate means stick next to each other. However, it's finding an integer, and so it's saying, I don't know how to do that, and so I'm going to bail out and stop. And when you get an error like this, the program will stop running, it will return you back to the terminal, and it will print an error like this on the screen so you can work out what's going on. So always start with the last line, because sometimes that's enough to let you know exactly what you did wrong and to let you know what's going on. If you've got a long program where your errors can crop up in all sorts of different places, it's worth looking at the lines above, which tell us where the error came from. This line here tells us which file we were on, which line we were on. We see it's on line 14. This is why programmers always have the line numbers turned on in their text editors. And then this line here in the output is the exact line that we had in our text file to give us context to let our brain jump back to the error a little bit more quickly. So with that, I'm going to ask you to have a go now at the exercise at the bottom of the data types chapter. So there's an exercise there to edit script.py so that it's made up of adding two strings together. So originally it said hello Python. In fact, I'll show you how it looked beforehand. It had something like my words equals hello Python, and then it was print my words. It might have had a different variable name, but that is not important. So have a go at taking this little program here, but breaking up this line here into two separate variables, one which has the word hello in, one which had the word Python in. Make a third variable, which is those two things added together, and then print that out and make sure it looks how you expect. Once you've done that, carry on to the end of that data types chapter. There's a section there on printing multiple things. So have a go at that, reading through that, and having a go at that exercise as well. Mengdi there has a question about, is there a difference between my underscore words and my words with or without the underscore? So the first thing I would say to that question, Mengdi, is the best way to find things out is to try them for yourself. You'll often discover something really interesting if you have a go with something and it works or doesn't work how you expect. That said, I will go through that with everyone because I think it's an interesting thing to look at. So here we made a variable called my underscore words. If I delete that underscore and put a space here, and then we try and run this script. I'm going to clear this and run the script. We get a syntax error. And the reason we get a syntax error on that first line is because Python starts reading at the beginning of the line. It sees the word my, and that's a variable name by itself. So the only thing that's able to follow a variable name by itself at the beginning of a line is an equal sign. It only makes sense if you're immediately following it to assign this variable a value. Because it sees the space as a break between two different variables, it's expecting there to be an equal sign next and not a space and some words. So this is telling us, the fact that we get a syntax error here, that my space words doesn't get seen by Python as a single thing. It gets seen as two separate things, a thing called my and a thing called words. And because they don't make sense next to each other, it's not understanding what you're trying to say here. So we need to put an underscore in. Sorry, an underscore. If we try that again, we'll probably still get an error. We do, but this time the error is on this line here because the same thing's happening. As an argument to the print function, it's expecting a single variable name. Here we're giving it two variable names separated by a space. It doesn't know what that means, and so it's going to give us a syntax error. So we need to have underscores. We could do it without any underscores at all and no space. That would work perfectly fine as well. The underscores are just there for visual clarity. Okay, so I'm going to show the answer to that exercise you were just working on. Hopefully you had a chance now to have a go with it. So as I explained to Mingdi, underscores are used for visual clarity and you can't use spaces in place of them. So we have our string here. We are going to change it into word 1, which is going to be hello. It's going to be word 2, which is going to be Python. And then my words is now word 1 plus word 2. We save and run this. And we see hello Python printed to the screen. The last section on that page was taking this example and making your life easier. You'll notice that you had to put a space here because when you add strings together, it doesn't automatically put a space in for you. If we get rid of that space and run our script, we get hello Python, all one word, which is not usually what we want. So what we can do with the print function is get rid of this line entirely and simply print word 1, comma, word 2. The comma here is telling the print function that we're giving it two separate variable names. It will take one, it will print it, then it will do a space automatically, and then it will print the second argument. So if we save and run this, we get hello Python back again. With that, I'm going to move on to the next section. At the bottom of that page there, if we press next, and we go down to the bottom, we press next, we end up on a chapter called lists. So this is when we start getting a little bit more interesting with things. So far we've been dealing with single pieces of information, a single number or a single set of words, a single string. But quite often in real life, and therefore quite often in programming languages, you want to deal with something that contains multiple objects. The example I always come back to that I think most well represents real life is a shopping list. You go to the shops and you have a list of things written down on a piece of paper. You have one shopping list, but inside that list you have a set or a list of items that you want to buy. You can think of each item as a string, but we need in our language some way to describe the list as a whole. The way we do that in Python is with a thing called a list. A list is a built-in type in Python, and it's what's called a container. It contains other pieces of data. So I'm going to switch back over to my editor and I'm going to make a new file. So I'm going to go to File, or not File, I'm going to click on the launcher and put it here and make another text file. So I've still got my old file here, but my new file here, I am going to rename it to list.py. So it's called list.py at the top, and then we can go ahead and close script.py. We don't need that one anymore. So I'm going to go ahead and make one of these containers. Like anything else, we start by giving it a name. You almost always want to give your variables names, and this is a really good way of making sure that you understand the kind of thing that's inside it. Same as before, we follow it with an equal sign because we want to give it some data. In the past, we would just write a number here or a string or do some kind of numerical work on some other data type. To make a list, we use square brackets. And I'll point this out at this point that in Python, there are lots of different types of brackets used in different situations. it really matters which type of bracket you use. So far we've used round brackets for calling functions, and here we're going to use square brackets to create a list. In between those square brackets, we put the things we want in our list. For example, cat, that's a string. We follow that item with a comma. Notice the comma's outside of the quotes. Dog, and let's put a number in as well, 261. So you see here we've got one list, one object that has three pieces of data inside it. Penguin, yeah, let's do a penguin as well. Thank you, Gareth. Penguin. You can have as many items as you want in a list. It's not limited to just 3 or 4. You can have lists with thousands of items if you so wish. You can also have lists with no items in. If we write it like that, that's a list with no items in. When we print our list, we can print it like any other variable. My_list. What's going on there? There we go. And we run it with Python list.py because our script is now called list.py. Run that and you see it's printed out the things that we put inside our list. It's got the square brackets printed out on the output to remind us that this is a list we're printing. It's got commas separating each item, and it's got quotes showing that these are strings. You'll notice that when you print it out, it uses single quotes, whereas when we made it, it had double quotes. That's because in Python, single quotes and double quotes are almost interchangeable with each other. There is a subtle difference between the two, but largely they mean the same thing. The convention is usually to use double quotes when making strings. However, regardless of what you make your string with, when it prints out, it will print with single quotes due to an older conventions. You know what conventions are like, they change every week. So have a go at that yourself. Make a list with some items inside it. Try putting some strings in there, some numbers, some floats, all sorts of different things. And make sure that you can print it out and it shows up on the screen correctly. Okay, so hopefully you've all managed to print a list out and that's all working for you. So we're going to move on and do something a bit more useful with a list than just making a block of a list and then taking that whole list and showing it to you on the screen. With a shopping list, you don't just deal with a shopping list on the whole, you deal with the items inside the shopping list. And so we need a way in our language to get access to the items inside. So we're going to make a new variable called myElement. Element is jargon generally for an item inside a list. Though the jargon isn't very consistent and you'll see it change later, but nonetheless it's often used for that. To get an item from inside a list, we write the name of the list and we follow it with square brackets. These square brackets that immediately follow the name of a variable are different conceptually to the square brackets we used when we made the list. If you've got square brackets by themselves with a space beforehand, that's you making a new list. If you've got square brackets and they immediately follow a variable name which is a list, that's you accessing things from the list. It's you asking a question of the list. We can put something inside those square brackets, kind of like a function call, to tell it what piece of information we want. So we can write, for example, number 1. And we want to not print the whole list, we want to just print that one element. So, audience participation time for those who are listening. Who wants to let me know in the chat what's going to get printed out when I run this script? And don't be shy. Okay, we've got some cats and some dogs. So those who are saying cat might be confused about how it could possibly be dog. Let's run it and find out what actually happens. We do indeed get dog. The reason for that is that in Python, everything starts counting from 0. When you're talking about elements in a list, the first element is actually the 0th element. This is item 0, this is item 1, this is item 2, and this is item 3. Everything in Python starts counting from 0, and it is very consistent with that, and so it's a thing that's worth remembering. If we change this to myList 0, at this point we should indeed get cat printed out. By that logic, if we want to get penguin, for Gareth there. If we do it with number 3, we should get penguin printed out. Next, pop quiz. What happens if I put in 7? What's going to get printed out here? Any guesses? Great, everyone's telling me that it's going to print an error. I expect by this point many of you are used to seeing errors because Python does throw them at you quite readily if it thinks you've done anything even slightly wrong. Over time you will learn to appreciate and love Python exceptions and errors, but when you're learning it can feel like you're being told off. The thing to remember is that it's just trying to tell you that it doesn't understand what you're telling it, and that it's thinking you might have made a mistake and it's trying to give you the information you need to fix it. Let's run this and find out. We do indeed get an error. Like before, we start reading at the bottom line. It is an index error. It's called an index because this operation with square brackets is sometimes called indexing. The actual text of the message here, list index out of range, is telling us that the list, my list, the index we're asking for, 7, is outside of the range of valid numbers. We only accept numbers from 0 to 3, so 7 is way out.
5 is right out.
And so it's going to give us an error. There's no valid answer we can give here. Notice that because it failed on line 3, which is here, the program stopped running. It didn't print an error and carry on. It stopped entirely. It never even tried to print my element. As soon as you get an error raised, the program just stops at that point and tells you what it knows about its state at that moment. So we know that 7 doesn't work, but 3 does. So far we've dealt with 0, 1, 2, 3. Those all worked. We've tried bigger numbers, 4, 5, 6 and 7. Those don't work. What do you think happens if I put in negative numbers? -1. Who wants to have a guess about what -1 is going to do? Costas thinks penguin, and you're not sure. Ricardo's guessing the same thing. Let's find out. Let's run it. We do indeed get penguin. We get the last element. So the designers of Python realised that all the positive numbers, including 0, if you count 0 as a positive number, are potentially valid inputs, depending on how big the list is. But you would never have any meaningful meaning applied to a negative index. It just doesn't make sense because we are counting. We aren't dealing with mathematical comparisons and so on. So they realised that because all the negative numbers are free to be used and they don't have any ambiguous meaning, you can use negative numbers for whatever you want. And they decided that -1 should mean the last item. And in fact, beyond that, negative numbers just count backwards along the list. So -2 will give us 261, -3 will give us dog, and -4 will give us cat. If we try and go to -5, we'll see that once again, we get an error. I'm just going to clear my screen up so that it doesn't disappear off the bottom. -5 gives us an error because indeed there's no negative things over here. It doesn't just loop around forever. It's bounded by the size of the array. The last thing I want to show you on this section, which comes to Rachel's question, and I'll come to your question in a moment, Rachel, once I've covered the basics of slicing, and that is, so far with indexing, we have simply selected individual numbers. We've asked for this element, or another element, or we've asked for something which doesn't exist by going off the beginning of the list or off the end of the list. It's quite common with lists or with any kind of container which has things in an order to want to grab a selection of items. So let's say we wanted to select items dog and 261. We can do that by using what's called a slice. It uses the same kind of syntax as we have here. So we still use the square brackets, but inside the square brackets we tell it where we want to start selecting from and where we want to end selecting from. So we want to select from here to here. So dog is item 2, and we want to go as far as but not including penguin. Dog is item 1, see, even I get mistakes. And we want to go as far as but not including penguin, which is item 3. The way I like to do the numbers here, because 1, 3 doesn't intuitively say to me those two items, is that I count the commas in the list as a way to remember what numbers I should put here. I imagine there's a 0th comma here because 0 is invisible, so there's no comma. So this is comma 1, this is comma 2, and this is comma 3. So if I want to select from this comma to that comma, I do 1, 3, and that's going to give me this slice of the list. So when I print this, I get dog and 261. It's this subset of the list. Now, coming to Rachel's question, she asked, is there a way to get, say, the last 3 elements? Because if you do -3, -1, it will print the last 3 and 2 elements, but not the last element. Okay, so let's work up towards that question. So here we've got 1 and -3. If you remember earlier on, number 3 referred to penguin, but also number -1 referred to penguin. So we can replace that 3 with -1 and say we want to go from comma 1 to comma -1. A little bit confusing, I know, but the more you do it, the more you'll get used to it. So this is going to give us that same set of numbers. Likewise, this is comma -1, -2, and -3. We could change this to be -3, -1, and we print this, and we get the same bit of information. Now, Rachel was asking, how can we get it to include penguin as well? If we change this to a 0, that's not going to work. It's going to try and go from here to here. There's nothing to represent this comma at the end. It's going to try and go backwards. And in fact, if we try and do this, it will give us an empty list because we've tried to index backwards, and so it's just going to fail. If we want to go right to the end of the list, there's a special shorthand, and that is you just leave that space there blank. You say go from -3 to infinity, effectively. And so when we run this, it's going to do dog, 261, and penguin. Likewise, if you do a blank at the beginning, it represents the beginning of the list. So just a colon by itself inside square brackets means right from the beginning until right at the end. So have a go at these exercises on this page here, the lists chapter. So get through as far as the slicing section if you can. The last thing I wanted to cover in this list section is how you can go about changing lists. So far the lists we've made have been static objects. They haven't had anything changing in them as we've been using them. But of course, lists are most useful if you can use them to collect information as you're going through your program, collect information in them, and then do something with that information at the end. So let's change our list here so it just contains animals. Let's delete this my element thing because we're not going to be grabbing something out of it. And let's print my list. This is now just going to print cat, dog, penguin. Let's pretend that what we're doing here is making a list of the animals that we have on our very strange farm. It's got cats and dogs and penguins. Maybe it's our pets. Maybe we've got a pet penguin. Maybe we're that lucky. In order to add something to a list, we write the name of the variable and follow it by a dot. After the dot, we write append. Append is a function, and so it takes brackets to call the function, just like print does. Inside those brackets, we pass an argument, which is the next thing that we want to add onto the list. Someone give me an example of an animal to add in here. Rat, there we go, wonderful. So when we run this, we will see we get cat, dog, penguin, and rat, all our pets. So what's going on here is we are referring to our list. This is the object, this is our data container that we have. By writing .append after it, we are calling a special kind of function, which is often called a method. That's just a bit of technical jargon, but they are relatively interchangeable terms, method or function, on our object. So the fact that it's a dot followed by the name of the function says that this function is going to be affecting this piece of data. And depending on what the append function does, it is going to take whatever's passed in and do that thing to my list. In this case, the append function takes whatever is at the end and takes whatever is passed in and adds it to the end of the list. Emma is asking, how do you add rat to be the second in my list? So there's two ways of interpreting that question, and I'll try and cover both of them. One is that maybe you are asking how you can overwrite the second item. So maybe you want to take what would be dog, second being number 1, remember, and you can assign that to be rat. This is going to take this list, then it's going to find my list 1, which is dog. It's going to overwrite it with rat. If we run that, we see that dog has become rat. If, however, you want to insert it into the list, this is where I can't remember everything. I believe there is an insert function. Let me just Google it, because that is how we learn. Python insert list. It sends the Python 2 documentation. We want the Python 3 documentation. Here we have the list.insert function. It takes 2 arguments. The first argument is the position, and the second argument is the item. I can never remember which way round they go. So we want to insert at position 1, and we want to insert rat. So when we run this, we see cat, rat, dog, penguin. Hopefully one of those 2 things is what you are asking about, Emma. So hopefully everyone's okay with lists. We can loop over them, we can grab items out, we can change things to do with them by appending to the end, and as we saw there, overwriting or inserting. So after the list section, we are on loops. So hopefully as we go through this, Olivia, I will explain the answer to your question, and I'll just read it out now so that I remember what it said. At the beginning of the loop section, you assign 2 variables called word with different strings. So does the variable store all the data that you assign to it? Okay, so I will go through that now. I didn't realise how soon it was. So let's make a new file, and let's call it loop.py. New file, text file, rename, loop.py. So the example I start with is writing something like, we've got word, hello, we're coming back to our examples from the beginning here, and then we print word. We run that, print hello. Of course it does. We've done that several times so far. I think we're all comfortable with printing and variables now. If we want to print 2 things, we could do word equals Python and then print word. When we run this, it runs line 1 to assign the variable, runs line 3 to print out hello, then runs line 5 to assign a variable, and then it runs line 7 to print hello. Olivia's question there was that we have assigned the variable word with the data hello, and then a few lines later we've assigned the same variable name with a different piece of information. What happens at this point in Python is that Python will forget anything about the history of the variable word. It will no longer know anything about the data hello. It will just know that word equals Python. Anything to do with hello from this point on in the program would be lost. It has no memory. It just remembers the most recent thing that you've done to it. The reason we get both hello and Python printed out is because we printed this one before we assigned the variable. This is one of the ways that variables in programming and variables in maths are different from each other. In maths, if you say something like a variable equals a number, you're stating some kind of mathematical fact that is then going to be always true for the rest of your analysis that you're doing. And so saying that word equals hello and then word equals Python doesn't make sense because it can't. A variable in maths can't have 2 different pieces of data associated with it. In programming, however, because we're going through sequentially, it does one and then it overwrites it with the second. The second thing that I hope you're thinking about this little bit of code here is that it looks very repetitive. We've basically written 2 lines of code and then written exactly the same 2 lines of code with one tiny little change. Every time we see something being repeated like this in a program, we should always think there's got to be a better way. Programmers are lazy. The best programmers are very lazy because they make the computer do the work for them. So let's get rid of this. Let's make this a variable words, and let's make this into a list. So here, instead of two variables and printing one at a time, we've got one variable, which is a list which contains two pieces of data. And we're currently printing the variable word, which previously was referring to one word and then the other. But what we have here is a container, a list. What we conceptually want to do to this container is for each item in that list, we want to print that item to the screen. When you want to do something to each item in a list, we use a thing in Python called a loop, or in this case, it's called a for loop, because we are doing something for each item. And so we introduce that using the word for, and you'll see immediately it goes green and bold in our editor here, so we know that it's understanding what we're writing. I'm going to write it out, and then I'm going to explain what these different parts mean. So the way I like to think about the structure of a for loop is first we just look at this line up here. This is the part that introduces the fact that we are going to be repeating ourselves. There's 5 different things in this line. 1, 2, 3, 4, and then the colon at the end, number 5. In every for loop you write, the for, the in, and the colon are always there, always in that order, and always spelt exactly like that. Those are the fixed scaffolding that we use to construct our repeating for loop. The places that we have flexibility and artistic license inside our for loop are in the other 2 locations, here and here. I'm going to start with the second of those, between the in and the colon. This is where we write the thing that we want to loop over. It is the thing that is the list that contains items that we want to do something to each item of. We want to do something to each item inside words, and so we are doing something for something in words. The thing we're looping over goes in this spot here. While we are repeating ourselves, while we are doing something to each item in this list, we need to give a name to the current item. We need some way to refer to it. Earlier on, we were referring to items inside a list using square brackets and numbers. But because here we're just going to be looping over the list, we don't care what number we're at. We are just going to be dealing with one item at a time as we're looping over the list. And so to make that work, we have to give each item as we come to it a name. We're only ever going to have one item in our hands at any one time. So only have to give one variable name. And the variable name we're going to use is word. It doesn't matter what you write here. You can give this variable any name you like. Like before, we had variables called mylist and distance in miles. In the same way, this is just a variable name we're creating. So the first time around the loop, this variable name word is going to be pointing at the first item in the list. Then the next time it loops around, this variable word is going to be referring to this item in the list. So the first time round, it's going to print word, so it's going to print hello. It is then going to repeat itself, and it's going to print Python. Let's check that that works. There we go. It prints out exactly the same thing as it did before, but what was previously 4 lines of code is now only 3 lines of code. Now that might seem like a small saving, but bear in mind that we could be looping over a list that had 1,000 items in which case this would still only be 3 lines of code. Whereas if we were having to print each item individually, it would be thousands of lines of code, and that is a lot of writing. The final thing I want to point out about loops, is that the colon at the end of the line in Python always designates that the next section of code should be indented. And that is why we have these spaces at the beginning of the line here. Python uses the fact that this is indented to know that these are the lines we want to repeat. If we write print dot dot dot, nope, in quotes, there we go. It is going to repeat, it's going to print this line and then this line, then repeat itself and do those two lines again. So if we run this, we see we get dot 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 hello, dot 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 Python. Likewise, we can print end, and it will do dot 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 hello end, dot 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 Python end. I'll just clear that. If we don't want this end to be repeated, all we have to do is unindent it, which you do by pressing backspace. Because this is no longer indented, this line of code will not be repeated. So when we run this, we get dot 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 hello, and then dot 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 Python. Then because the loop's finished, because words has run out of words, it then exits the loop, unindents, and then runs this line of code just once. So have a go at the exercises on the loops chapter. Do the first exercise on there first, and then if you've got time, move on to the exercise at the bottom of the page. Don't go quite as far as enumerating, because I'll be covering that in just a moment. There's a question there from Sam. We use 0 and 1 in last exercise. Why can't you do that again? So you're saying, why can't we do print words 0. I'm going to delete those. And print words 1. There's no reason why you can't do that. And if we look, we'll see that those two things come out exactly the same. But if we have hi, it's Matt here, then we'd have to do 0, 1, and do a 2, and then a 3, and then a 4, and that's probably not even the right number. Hi, it's Matt, and I didn't miscount it, so they have to do a 5. And so then it's done the right thing. Hi, it's Matt here. But we've had to copy and paste. We have to repeat ourselves. It's very easy to accidentally do that and not notice that you've got a number repeated. Also, if you've got lots of items, you have to do lots of lines of code. This will always just be those 2 lines of code, regardless of how many items you have in the list. It's quite common with lists that as you're collecting your data, you don't know whether you have 99 or 101 items. You just know that you have a container with information in, and you want to do something to each of those numbers. Maybe you want to double them, maybe you want to print them, maybe you want to email everyone that's in that list because it's a list of email addresses. You don't care about where each item is, you just care that there's a whole bunch in there. So yes, it certainly is possible, but looping gives us the flexibility that we wouldn't otherwise have. Kunal asks, what if we want to print each item twice? Let's have a look. I'm going to simplify this back to where we were. So here we do this and it prints each item once. If we want to print it twice, we can just write print word twice inside it. If you want to do it 3 times, well, we could copy and paste it again. But as you can see, we're probably starting to get the point where we're repeating ourselves quite a lot. So as Gareth says in the chat, you can actually make a loop inside your loop. You could do another for repeat in. And the way that you repeat things a certain number of times is by using the range function, range 3, print word. And here, when we run this, we get it happening 3 times and 3 times. So then if we want to do it 100 times, we could just change that to 100. And it would print each word 100 times. Yes, so range is a special word. Or rather, it's a built-in function. In the same way that print is a built-in function, range is a built-in function. The job of the print function is to take the argument and display it on the screen. The job of the range function is to take the argument and to give us back a list containing that many numbers. Ronald, I'm glad you asked, because that's exactly the next little section, which I'm going to cover now, and then we're going to have a little break for a bit, because we've been at this for nearly an hour and a half. So let's have a look at how to answer Ronald's question. So they're asking, what's a concise way for accessing the current index / iteration inside the loop? So here we are looping over for word in words. The thing that we're looping over is this list. And when you loop over a list, the thing you get given each time is each item in order. If you want to get each item and its position, there's another function called enumerate, which means give numbers to, which when we run it, we get back the index and the item. It gets given this back to us in this form with the brackets and the commas and stuff, which is useful, but it means that we can't access those two pieces of information separately from each other. So if we want to get access to the two things individually, we can take the fact that enumerate is giving us back a pair of things each time. And so instead of having one variable name here, we can have two variables separated by commas, where I is going to be assigned the first thing that's given back, 0 the first time, and word is going to be assigned the second thing that's given back, hello. So then now if we print item I is word, it'll print item 0 is hello, item 1 is Python. Kunal's question. So that's a question about documentation. How do I find suitable function for my tasks? There can be 100 built-in functions which I don't know about. So let's go to docs.python.org, exactly as Gareth's linked there. So the page that I was on before was a page called built-in functions. So you can go to the search, built-in functions, and then you can never find them. So what happens here is I go to Google and I search for Python built-ins, which is almost certainly what Gareth did. And there's a link here to built-in functions. And we have here a list of all the built-in functions, which include print and enumerate and range. And that gives you information about what's going on there. In general, the Python documentation will have information about every single thing you can do with Python the language. It's not always easy to navigate through here. So on the whole, the way I get there is by Googling for Python followed by the thing I want to search for. Like Python insert into list is what I searched for earlier. That will take me to the Python documentation. I end up in the right place. The thing to make sure you're doing on the Python documentation page is the link, there's a drop-down menu with different versions. Make sure you're not on the Python 2.7 page. You'll be able to recognize it because the 2.7 documentation is all blue and it's got a big banner at the top. So in that situation, click on the link here and click on the latest number up at the top. And that will take you to the current version's documentation. Ronald asking a question, do you take a bigger performance hit if enumerating a long list versus just adding a counter inside the for loop? So no, the way that enumerate works is that it only generates the indices as it needs them. It doesn't generate a big list in advance, it just keeps track along the way. So it's doing that counter inside the for loop thing for you automatically, which means you don't need to worry about setting it to 0 before the loop and anything like that. It just does all that stuff automatically. So there's no performance hit at all. It does it all dynamically on the fly. That said, if you're worrying about performance with a really, really long Python list, you're probably at the point where you want to start looking at more advanced Python tools. So there's a set of tools called numerical Python, sometimes abbreviated to NumPy or NumPy, that will have the tools in there for doing that kind of stuff nice and efficiently. And also in our Python Introduction to Data Analysis course, which Gary was just asking about, where you go through a package called Pandas, which provides tools for doing this stuff nice and efficiently as well. So once you're at the point of worrying about performance, it's worth looking outside the built-in Python lists at what other tools are out there. Ronald, your question, is it possible to have local dummy variables inside a loop? Yes, it absolutely is. So I'll just demonstrate that quickly here. Let's make a variable called my number equals 42, and then let's just print my number. And when we run that, we see it prints the thing out and it prints out the variable as well. So you can introduce variables inside the loop and then they just sort of live inside that scope. So before the break, we were covering loops. That's how we perform the same operation multiple times. So to look at the example we have up here, we were doing this line of code, which we've only written once, but it's going to be performed multiple times. So you write a line of code once and it runs many times. The other kind of thing you want to do to your code sometimes is to write a line of code which may or may not be run at all, depending on the context and the situation around it. The way we do that in Python is by using what's called a conditional. So let's make a new file and let's call it if.py, because that is the question that we are asking. If. Let's make a variable. That's how we start almost all of our scripts. Number equals 128. Nice computery number. The way we ask questions of our data in Python is by using the if keyword. This works similarly to the for loop keyword that we had before. And you'll see it's done the same thing where it's gone the green and it's bolded up as well. After the if, we are going to write something here, followed by a colon. Similar to the for loop where we had our scaffolding of the for, here we have the word if, and we have a colon at the end of the line. The question that we ask can be a whole bunch of different things. So I'm going to give an example and then I'm going to let you have a go at running that yourself, and then I'm going to be building it up bit by bit. One of the simplest questions you can ask is to compare the size of numbers. So let's say, is my number greater than 100? So this bit here is whatever we want it to be, as long as it's giving back something which is true or false. This means greater than, and if you have something on the left and the right that are numbers, it will compare them and give us back true or false, depending on whether they are bigger or not. If this thing returns true, if my number is bigger than 100, then it will run whatever code is indented in the block below, which in this case is going to be our trusty print statement. My number is large. So if my number is bigger than 100, it will run this line. If my number is smaller than 100, it won't run that line at all. Oh, no, that's not what I meant to do. That's what I meant to do. Python if.py. 128 is large. Copy that code into your own script, into a file called if.py. Do the same things I just did there and make sure it prints out the same output. Then try changing my number to be different things. Negative numbers, numbers that are near to 100, numbers that are small, numbers that are much bigger than 100. See what you get, have a little play, and make sure you understand what answers it's giving you back. So I had a go here and I set my number to be 999 and it likewise printed 999 is large. But if we make this smaller than 100, like 50, and we run it, nothing gets printed out. It just does nothing at all. So if we wanted to print out something if our number is less than 100, we need to use a different operation. Instead of saying, is it greater than 100? Let's change this to be less than, and let's say, is it small? So now when we run this, it says 50 is small. As well as, I'm just going to do some stuff down here. So greater than means greater than. This means less than. Greater than sign followed by an equal sign means greater than or equal. Hopefully you can guess that that means greater than or, no, sorry, doesn't mean that at all. It means less than or equal. If you want to check whether two numbers are exactly the same as each other, you use two equal signs next to each other. If you use a single equal sign, it will give you an error. If you want to compare numbers, you use two equal signs. Are they equal? And if you want to check that they are not equal, you can use exclamation mark equal sign. Are not equal. Are they? Let's be grammatical. So have a go now at tweaking your if statement to use a different sign. Update the little comment so that it does something that we print something that makes sense. just have a little play with a few different operators, as they're called there, and see and check that they make sense to you, and then we'll be moving on to the next little section. If everyone's happy with that, everyone's had a chance to play around with different signs and check that it all works for them, then I'll move on to the next little section. I'm going to delete that because it's not valid Python code and it will give us a big old syntax error if we try and run it. It was just a comment. So a question you might have thought of is, I wanted to do one thing when it's greater than 100, and we say it's large. And then if we wanted to print something when it's smaller than 100, we had to delete the code and change it and make it say something else. What we'd usually want to do is to do one line of code if this condition passes, or a separate line of code only in the situation where that line of code doesn't pass. And we can do that using a statement called an else. An else statement in Python always has to follow an if. By that I mean you can have an if statement with no else, but you can't have an else with no if. So you just write else and a colon, and here we write print my number, if I could spell, is small. And so now we can run if.py, it says 50 is small, we can say 990 is large. If we do 100 exactly, it tells us that 100 is small, because 100 is not greater than 100, it is equal to 100. Okay, so Olivia has a question about the indentation here. So the indentation here gets interesting. There is a consistency across Python with how indentation is treated, so it's worth taking some time to understand what's going on. The way that indentation gets applied is any line that's indented is always associated with a colon before, and that colon and the indentation associates this block of code with this statement here. So we could print hello as well. So these two lines of code are indented, so they're associated with the if passing. This block of code is indented after following this colon, and so it's associated with this else. The if and the else are at the same indentation level because the else kind of sits next to the if, it's not inside it. And as I introduce the next statement here, you'll hopefully see why we don't keep on indenting, because you'll see that things get a bit messy. Because we might want to here do one thing if it's greater than 100, another thing if it's less than 100, but a third thing if it's exactly equal to 100. And for that, there's a thing called an else if. So here we say, if this thing's true, do this thing. Otherwise, if this thing's true, which let's make this my number is equal to 100, print my number is 100. And if that one's not true either, then it finally goes to the else. The reason you want to do that, and let's just check that works. Here we say, oh, we've got a syntax error. Of course, that was for demonstration purposes. In Python, you don't write else if, you write elif. It's an abbreviation they introduced for whatever reason. Here it says 100 is 100, because it's taken this number, my number. It's not larger than 100. It is equal to 100, and so it's printed this, and then it stops checking. When you're going through a chain of ifs, elifs, and elses, it will check from top to bottom. The first one that matches will run that block of code, and then it will drop out and not check anymore. And the reason you don't want to keep on indenting these things is because you can have as many elifs as you want. You can obviously have 0, because we saw that already. But you could also have a second one which checks if it's 42. So 100 is 100. 42 is 42. And 13 is small. If each of these times we had to indent our code, we would end up disappearing off the right-hand side of the page by the time we checked all our different conditions. And that is why we don't have to indent each block as we get to it. So for the exercise here, I want you to take this block of code or a similar block of code if you've got different else's and ifs, and put it all inside a loop. Remember before I showed that you can nest loops inside of other loops? You can also nest if statements inside of loops, and vice versa. So take these lines of code, nest them inside a loop, and loop over a list of numbers, and check each of those numbers in turn and print out whether they're large or small or whatever else you want to check up on. I'm going to do it alongside you all on the screen here so that you can see how it works, and then I'll check back with you in a few minutes and then we'll be ready to move on to the next section. So this is the exercise at the bottom of the conditionals chapter. Okay, so we've got one person's finished now. I'm going to go through the exercise answer with you all now to explain how it's done so we can move on to the next section. But with any of this stuff, I'll give you information at the end to do on how to get in contact with us afterwards. But we've got a quick question here from Olivia, asking about the difference between the numbers and range. So in my example here, I want to loop over the numbers 0 to 9, and so I've used the range function to give us access to them. The other way we could have done that is by doing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Both of those are going to give us basically exactly the same answer, with the difference being that we've had to type a whole lot more for doing it explicitly. Secondly, if we wanted to loop over the numbers 0 to 10,000, it would grind our fingers to the bone having to type it all out. Whereas doing it using range, we just do that, and it's immediately going to give us access to them all. So that's one of the reasons to use range instead. But we start off with my numbers equals range 10, which as we saw before, give us the numbers from 0 up to 10, but not including 10. So that gives us the numbers 0 to 9. The if statements inside here are exactly the same type of thing as we were doing before. Is a number bigger than 5? Is it less than 5? Or is it neither of the two, in which case, well, it must be equal to 5, mathematically. The thing that we have done extra here is that we have indented all of this, as you can see. And we've done that because it is now inside a for loop. We are now going to be repeating this set of if statements multiple times. We are going to be doing it once for each of the items in my numbers, which is the numbers 0 to 9. Each time around that loop, we are going to have the variable num. So inside each loop, the variable num is going to be referring to first the number 0, then 1, then 2, then 3, etc, etc. And so it's that number which we are comparing in each of these situations and printing out. So when we run this code, we get, first of all, we get the first item from range 10, which is 0, which goes into the variable num, which gets compared to this. It is not greater than 5, so it goes to this one. It is less than 5, and so it prints out less than 5. Does the same thing for the rest of them until it gets to number 5, at which point it's not greater than, it's not less than, and so it does this block. Then it carries on through, and then all of the rest of the numbers are matched by the first block there. So this is to show that you can put if statements inside for loops, and it all just kind of works how you expect. In this block here, you can put some blank lines in here. You can look at this block of code, and even outside of the context of you knowing that you're inside a loop, this section of code still makes sense in itself, as long as you trust that there's a variable called num that you have access to. It doesn't matter to these lines of code that they're inside a loop. They are just doing the same if, else, elif, and else thing that they always do. In our case, however, we do want to make it clear that it's inside a loop because that's how we know that we're looping over the numbers. You'll use if statements a lot in your code. I find it quite uncommon to use elif. It's a corner case catching tool rather than everyday tool, but certainly I use a lot of if statements. I use a decent amount of else's, and I always use loads of for loops in my code. That is one of the most common things that I do in my code, is looping over stuff and repeating myself for each item inside a list. And Kunal asked, there are a lot of variations of if in Python, right? Yes, there's ifs and elifs and elses, and there's lots of different things you can put here. It gets quite complex to allow you to explain to the computer all of the different things that you might want to do. So I'm going to move on to the next section now. So after the loop section, I'm behind on the notes on the screen here. And after the conditional section, we move on to dictionaries. I'm going to make a new text file again. It's always good to make a new text file for each section of code that you're writing. And I'm going to call this one dict.py. Dict is the usual abbreviation for dictionaries in Python, and you'll see that cropping up a lot. So get used to dict meaning dictionary. And now I'm going to explain what a dictionary is. So a dictionary is similar to a list. Lists were containers which held multiple pieces of data. They held them in a certain order, and we could access them either by looping over the list or by asking for specific items in the square brackets, asking for item 3 or 0 or -2. A dictionary works in a similar way. It's a container which holds multiple pieces of data, but rather than holding them simply linearly all in a line and giving each of them a number to refer to it, we instead give each item in our dictionary a name or a key which we use to access it. You can think of it a bit like a physical dictionary where you have a bunch of words and their definitions. You look up the definition of a word by finding the word in there, and then the definition is associated with it. Let's look at an example now to see how it looks in code. So I'm going to make a dictionary which contains animal sounds, continuing our animal theme from earlier. So I'm going to make a dictionary called sounds, and inside this I'm going to make a dictionary. A dictionary is made using curly brackets. Now those are different to the square brackets, and they're different to the round brackets. Curly brackets in Python almost always mean I am making a dictionary, in the same way that square brackets by themselves meant I am making a list. So once again, inside the curly brackets, that's where we put our contents of our list. Each item in a dictionary is a pair of items in this case. So we have here cat and meow. Those two things together, separated by a colon, are a single item in the dictionary because each item in the dictionary is a key and the value. We can add multiple here, for example, dog and woof. Sorry, that should be a colon. So here we have one item, which is this pair of things, and another item, which is this pair of things. Each item in a dictionary is made up of two parts: the key, which goes before the colon, and the value, which goes after it. I tend to, when I write dictionaries out, spread them over multiple lines because I find it a little bit easier to read. When you've got this many symbols hanging around, it can get a bit messy to the eye. So one thing you can do with dictionaries, and in fact with many things in Python, is spread them over multiple lines. So I'm going to put a new line in there, a new line after that comma, and a new line before that closing bracket. So this is exactly the same thing. It works in the same way, but it makes the fact that this item and this item are separate a bit clearer. Oh, sorry. So I'm going to ask in the chat, I need more than 2 items for my list because 2 is a bit boring. What other animals and sounds shall I put in here? We had penguin earlier on. What sound does a penguin make? Because I don't know. Gareth? Apparently they go meep. And we also had fox. There we go. Thanks, Maddie. Now, what does the fox say? Screech. That sounds about right. I had one in the garden the other day, and it made a very horrible noise. And we've got a duck. Duck. Going honk. And we have a sheep. And what noise does sheep make? Bah. Lots of A's. There we go. So, once we've got our dictionary full of items, each of these is an item. We have a key and a value associated with each. We get things out of the dictionary in the same way that we did with lists. So we're going to make a new variable cat sound, and we want to get from this dictionary the sound of a cat. So we go to sounds, we use square brackets, But this time inside the square brackets, we don't write the number of the position of where the thing we're looking for is. We put in the square brackets the key of the item we're looking up, for example, penguin, and it will give us back the associated value, which in this case would be meep. So if you put cat in there, it's going to give us back, hopefully, meow. Let's print it and check cat sound. Oh, no, wrong file. Python dict.py. Invalid syntax. I've missed a comma there. Very easy to do. Cat sound. I made a typo. Tell it's getting late when I'm making that many typos. It prints out meow. It's looked up the key we put in. It looks up in here. It's given us meow. If we change this to be just sound, because we're going to be tweaking what animal this is, change it to fox and print that, it makes a screech noise. So have a go of that yourself. Copy in that dictionary, try grabbing items out of it, and also see what happens if you ask for an item from a dictionary that isn't in there. For example, if you make a typo here, or you ask for an animal which isn't in there at all. Olivia asks, do you have to have a comma after the last key in the dictionary? No, you don't. That works just as well. The reason I tend to put a comma after the last item when each is on its own line is because when I add a new item, I only have to worry about this line here. I don't have to remember add a new item like fish, bubble, and then, oh, I missed the comma there, which is exactly what I did wrong earlier. So I tend to always put a comma at the end of the line to avoid me making that mistake. Also, when you come to use version control like git later on, it makes your differences between files a little bit neater to read if you have a comma at the end of each line. But largely, it's a matter of style. I will sometimes use one or the other. Gary is asking, why does the dictionary use square brackets to search the items, not curly brackets? So this is where it gets a bit confusing with Python and the different kinds of brackets. Or at least it does seem confusing at first, but I'll try and explain the logic behind it. So the reason that we use different types of brackets for creating the different types of objects is to make it unambiguous when Python is reading the file what kind of object we're trying to create. And that is why right from the start you have to choose when creating something whether it's going to be square brackets to be a list, curly brackets to be a dictionary, or there are other types of brackets which get used as well. As for accessing stuff from lists, it's not ambiguous what we're asking for with the square brackets here, because each type of object can only be searched in one way. So if this were a list, then Python knows that square brackets is asking for it by number. This is a dictionary here, so Python knows that square brackets is asking for an item from it by its key. That allows Python to always use square brackets to mean give me something out of this list. And the syntax would always look the same, so you can look at the line like this and you don't really care whether sounds is a list or a dictionary or some other exotic type of data. All you care about at the reader of the code is that we know this is something which must contain stuff because we're asking for something from inside it, and we trust that the thing, in this case sounds, knows how to interpret it. The other reason is because there are lots and lots of different kinds of containers, beyond lists and dictionaries, which have their own syntax here. In more advanced Python tools, there are other tools which don't have their own individual way of creating with special brackets, but they are accessible using square brackets. And so by allowing square brackets to be the generic syntax for give me something from inside this thing, it makes the language nice and extensible. Now I'm going to move on to the next little section. Like we did with lists, we created our list statically, we've created our dictionary statically, it's fixed in the file. With lists, we could add items into it by using append, and we also saw the insert function when I was answering someone's question. Dictionaries have a similar ability. So I'm going to get rid of sounds fox. If we want to add a new item into a dictionary, we do it just by accessing it. So can someone in the chat give me another animal and a sound? Tiger. And what sound do tigers make? Grr. Okay, cool. That's scary. So you do it by accessing the item as if you're trying to get it out. But if it's not in there, because we've given it a value on the right-hand side, it's going to insert that into it. And that means we can now do sound equals sounds tiger, and this will print out grr. Ronald is asking, can you modify the name of the key without changing the value? So we can change the contents of a value by doing this same thing. We could have put, for example, duck there and maybe make this a scary duck. But if you want to change a key, it's a little bit trickier. So you would have to, for example, let's say we've called this, let's say we made a typo, we called Tigger by accident. We would have to make a new one, sounds tiger equals sounds Tigger. And then we'd have to delete sounds Tigger. So it's a two-step process. So we put in an incorrect name there. We've then renamed it, and we can access it by the correct name, and that should work. So have a go at that yourself. Try adding in a new entry into the dictionary. Make sure it makes sense when you're doing it. Try overwriting existing variables, and I'll come back in a minute or so to move on to the next section. I'm going to cover the last section on dictionaries here before we move on to the last chapter in the course today. We're doing well for time, I think. And it's following the same kind of pattern to what we did with lists. With lists, we looked at making them statically, getting items out of them, changing items inside them, and then we moved on to looping over them. And when we loop over a list, we repeat each line inside the loop body once for each item in the list, and it works in a very similar way with dictionaries. So let's put tiger inside here, because I don't want to leave any animals behind. So when we loop over a dictionary, let's find out what happens. The nice thing about Python looping and for loops is that they are very, very generic tools. You can loop over lots and lots of different types of things in Python, while the syntax you use basically stays the same. It doesn't matter whether you're looping over a list, or a string, or a dictionary, or as we'll see in the next section, a file. The words that you write on the page look very similar, and it's a general way of repeating yourselves depending on the kind of container that you want to loop over. So here we want to some kind of thing in sounds. And I'm saying thing because when we looped over a list, it was unambiguous what we'd get back. We had one item at a time. Here we've got two different things. We've got a key and a value, or potentially the whole thing all at once. And let's pretend we don't yet know which of those we are going to get back. And let's print thing and find out what thing is. So when we've looped over this dictionary, we've said we want to have whatever it is that looping over it gives us, and Python's decided that for us. And it looks like, looking at the output, that when we loop over a dictionary, we get back the keys from that dictionary. Cat, dog, penguin, fox, duck, sheep, fish, tiger. Those are the keys in our dictionary. It hasn't given us access to the values. So we now know that this isn't thing, this is a key. Again, the variable name doesn't matter, but it's good to use one that's descriptive. But better than that, actually our key isn't just a key, it's an animal. And suddenly this loop here is starting to read a little bit more like a human would understand it. For each animal in our sounds dictionary, print out the name of the animal. And that's what we get over here. If we want to get access to the values, there is a thing we can do where, like with the append function to a list, we do a dot values after the thing we're looping over, and that's going to give us back each of the values. So we now change this to sound and sound. Now it's giving us back each of the values one at a time. If you want to explicitly loop over the keys from the dictionary, like we had before, we can do that too by writing keys there and changing this back to animal. So if you have sounds by itself, it gives you back the keys. If you do keys explicitly, it gives you back exactly the same thing. Sometimes it's good to do it this way because it reminds you that it's giving you back the keys. The final thing that you sometimes want to do with dictionaries is not get back a list of just the keys or just the values. Sometimes you want to get back both of the things at once as a pair. Because as you can see in the output over here, the keys and the values have been disassociated from each other. There's no way to know which sound and which animal are related to each other. In order to get them coming out in pairs, there is a third thing that we can pass in here called items. Remember I said earlier that an item in a dictionary is this pair here, or this pair here, or this pair here? That terminology carries across to this function here. So when we ask for the items, it's going to give us back cat, meow, etc., etc. So let's have a look and let's call this thing again. And when we print this, we see it gives us back these pairs. Now these pairs work in a very similar way, well in fact exactly the same way, as we saw with enumerate earlier. With enumerate, we solve the problem of it printing out it with the brackets and the quotes by putting two variable names in here. And we can do the same thing with items. So we can write, for example, for animal, because the first thing we're getting back here is the animal, comma, sound. And then our print statement, we can say animal goes sound. And when we run this, it writes cat goes meow, dog goes woof, etc., etc. This is a very common thing I do to be able to loop through a dictionary and get access to everything. But each iteration of the loop, I'm only being given access to one of the items, so the key and the value at a time. But that's really useful to allow me to go through and do something to each of the things inside the dictionary. Some questions in the chat there. So Rosalia is asking, my list is printing in a different order. Is that an issue? No, it's not. So until Python 3 point something, 3.4 or 3.5, the order of a dictionary wasn't preserved. So the order you wrote it here could easily end up being different to the order it's printed out at the end. As of a recent version of Python, they've changed it so that it's always preserving the order. But in general, it's good to not rely on the order of a dictionary. Treat it as a bag you've thrown a bunch of items into, and each time you loop over it, you stick your hand in and grab them in a random order. Assume that's the case, even if they end up coming out in the order you put them in. That's the safest way. And Amanda asks, can I assign more than one value to a key? You can. So let's look at dog. So here we've got dog making a woof noise. If we wanted to assign a list of values to it, we could say woof and bark. And so now when we print it out, we get dog goes woof bark. Of course, this isn't a very nice way of printing it. So we might want to have an if statement in here, which has something like if animal is equal to dog, animal goes sound 0 and sound 1. Make that a little bit bigger. So here we have assigned dog to have two values, and so when looping over it, we check if we're on dog. If we are, then we print both of the sounds. Otherwise, we print the one sound. And we look at that, and we see dog goes woof and bark, and the rest are just carrying on. So here we're combining together dictionaries, loops, and if statements all together. So have a go at running those things yourself, looping over items, keys, and values. Check you're happy with it, and then I'm going to be moving on to the final section in the course today, and that is reading files. Just take a few minutes there, and then I will be moving on. Salim, yes, the something going something is a strange Englishism which is a bit weird to translate. So we could instead write animal makes this noise. And then it says penguin makes this noise, meep. Fox makes this noise, screech. If that's easier for you to read or something, then go ahead and change it to that, and that might make it a little bit easier to understand what's going on. Emma asks, can you make the code detect that the dog has two sounds? Yes, we can. There's a few ways we can do it. I'm going to try and not use a way that's too confusing for new learners of Python. But we could, for example, do if there's a thing you can do called isInstance in Python, which checks what kind of data something is. And we could say if isInstance sound list. Let's see if this works. It then does the correct thing for dog. So this is saying if sound is an instance of the list type, then do this. Otherwise, just print it out on the screen. That's one way to do it. There is, in general, lots of ways to do things in most programming languages, and part of the job is working out which one's right today. The last thing I want to cover here in the dictionary section is right at the bottom of the dictionaries chapter. There's a little list of things that you can loop over. And I just want to draw your attention to that because we're going to be building on this in the next section. But to reiterate, when you have a for loop, the thing that you put in this section between the in and the colon can be a list or a string or an enumerate function, or we saw range earlier, which isn't listed here, or dictionaries, or the keys of dictionaries, or the values of dictionaries, or the items from dictionaries. All of those things are possible, all with exactly the same syntax on this line here. The only thing you change is what you're looping over. Python has a very extensible and generic way of looping over things. So much so that we can loop over objects that aren't even part of the language itself. For example, files. So the last section we're going to do today is this last chapter here, files. So I'm going to make a new file, text file. I'm going to call it, maybe confusingly, file.py. And in here I'm going to also make a file. I'm going to make a second file, which I'm going to move down here. And I'm going to call this data.txt. And inside here I'm just going to write some, this is a file. So I made two files here, a Python file and a text file. And what we're going to do is write a program which can read this text file and display it on the screen. So the way we start this is by writing open and then the name of the file that we want to open. The file by default has to be in the directory that you're running your code from. In this case, it's data.txt. In order to handle the file being automatically opened and closed, we need to introduce a new thing called it's called a context manager, but they're sometimes called with statements. And that's because it starts with and then has as f. And what this is saying is open this file, make a new variable called f, which is going to be referring to this file. It's our handle, which we're going to use to, hold on to refer to this file. And the with part is saying, because we've got the colon here, everything inside the next block is dealing with it while the file is open. And as soon as we finish and unindent, the file will be automatically closed. The reason to keep track of whether files are open or closed is because A, you can only have so many files open at once, and B, in some operating systems, only one program can have a file open at once. So it's good to be careful and judicious about closing your files when you've finished dealing with them. And that's what this with statement handles for us automatically. So with the file being open, we can do something to it. And the most basic thing you can do to a file, as I was alluding to before, is loop over it. So we can write for line in f, print line. We then run our script, What's it called? File.py. And it's printed out, hello, this is a file. Almost exactly as we saw there. The thing that's different between the two is that here we have no blank lines, but here we've ended up with blank lines after every single time it's printed. The way to fix that, or the reason that's happening, is because every line in a file has the word HELLO, and then it actually has an invisible character at the end of every line called a new line or a carriage return, which tells it to go move on to the next line. Now that's fine, except that the print statement also always prints something and then does a new line for the next time. So we're getting a new line being printed from the file itself and another new line coming from the print statement. So we end up with 2 new lines after every thing that we print. To fix that, there's a few ways of doing it. The easiest way is to tell the print statement not to print its own new line. So you can do that by passing a second argument to print, the end argument, and just give it an empty string. By default, end is /n, which means print a new line. If we tell it to do nothing after printing each line, it will then print our file correctly. I'm getting something funny happening there, so I am going to do... Ignore me for a second. There we go. So we say, hello, this is, and then we say a file at the end. So it's printed it. It hasn't printed a new line after a file, and then it's printed my prompt straight away afterwards. So that looks a bit messy. So let's see if there's another way we can do this. So maybe instead of suppressing the new line that's coming from the print statement, we instead suppress the new line that's coming from the file. So the way we can do that is we can take line and we can assign it to be line, but there's a method you can call on all strings called strip. And what strip does is remove any spaces or new lines from the beginning and the end of the line. That will therefore get rid of the new lines that are coming from the file and leave us only with those coming from our script here. And that means we can move back to here and we can run Python file.py now after saving this one. And now it does the correct thing. So what we've done there, we've called the strip method on each line of our file, which has got rid of the extra new lines that are kind of hanging around. So have a go at doing that yourself, reading in a file. Doesn't matter what file you put here, as long as it's in the same directory as everything else. And make sure you're happy being able to read it in, stripping the new lines that come with the file, and then printing out each line. I'll just cover now the last thing I want to talk about in files, since we've only got a few minutes left of the session. And that is how files deal with data types. So I'm going to change my data.txt down here to have some numbers in. 42, 9013. If we now run this again, we get those numbers printed out. Now we know that we're looping over numbers. We want to be able to do something like print line times 2. Maybe we want to double each of these numbers to get 62, 18,000 and 26. So if we run this now, see what happens. We get something strange. Instead of doubling the numbers to be 84, it's doubled the string. That's very strange. The reason it's doing that is because it's reading everything from this data file as if it is text, even if it is a number. If we know that everything in here is a number, then what we need to do is, once we've stripped it, to also convert it to a number by using, for example, the integer function. This is going to take what was line with new lines, strip off the new lines so it's just the digits, then convert it to be an actual integer, so that then we can do mathematical operations on it. This is like the difference between 2 in quotes and 2 by itself. So now when we run this, it does the correct thing. So a question there from Salim about art of knowing all the things that you need to do. As Gareth says, it just comes with practice. The more you do it, the more you learn stuff. I've been doing Python for 10 years or something now, so this stuff just becomes second nature the more you do this stuff. You shouldn't expect to be an expert at Python after a 3-hour session one afternoon. It takes time. But there's lots of people learning with you, and there's lots of people who can help. So that's the last thing in the file section. The very last summary section here has on it a big difficult exercise, which I'm leaving as a homework exercise for you if you'd like to carry on with this after the session. With that, I'm pretty much going to wrap up. Thank you very much for attending, and I'll hopefully see you all soon.